Simulations suggest this dark matter played a key role in shaping Tucana 2 and other very early galaxies right from the beginning, gathering regular matter into clumps and building the first galaxies.
The importance of dark matter really can't be overstated. It has actually controlled the way matter has evolved since the beginning of the universe. It brings matter together. You need this underlying structure of dark matter to make it all happen.
Scientists think that for billions of years, as the early universe grew, dark matter called the shots. Without its gravity, structures like the Milky Way wouldn't have formed.
All stars grow and change throughout their lives. Some stars explode at the end of their lives, and we call those explosions supernovae. This happens to stars that are very large, much larger than our Sun. Our Sun, which is a medium-mass star, will instead eventually discard its outer layers, exposing just the core. This core is small, hot, and bright, and roughly the size of the Earth. We call it a white dwarf. White dwarfs don't explode, unless they eat too much and gain too much mass. An explosion like this is called a Type 1a supernova. When white dwarfs explode, they always give off about the same amount of light, and this means that we can use them to measure distances in the universe. Just as distant streetlights look dimmer than ones closer to us, distant Type 1a supernovae look dimmer than nearby supernovae. This is how we can work out distances. When astronomers used this technique, they found some very interesting information about the universe. They discovered that the expansion of the universe hasn't been slowing down since the Big Bang, but speeding up.
On January 21st, 2019, for the very first time, NASA's TESS saw a black hole destroy a star. This was a tidal disruption event, which occurs when a star passes too close to a black hole. Extreme gravity causes the star to bulge and break apart into a stream of gas. The tail of the stream escapes into space, but the rest swings around to form an accretion disk. This event, called Assassin 19BT for the All-Sky Automated Survey for Supernovae, which first identified it, happened in the TESS Continuous Viewing Zone. TESS's 4 cameras scan large sectors of the sky, and one constantly monitored this region for a full year. TESS saw Assassin 19BT as soon as it started to brighten, days before other observatories spotted it. NASA's SWIFT satellite quickly observed the outburst in visible light, UV, and, along with the European XMM Newton satellite, X-rays. The UV measurements are the earliest recorded for a tidal disruption to date. They showed the event's temperature dropped almost 50% in just a few days. Such a steep decrease has never been seen in a tidal disruption before. These outbursts are rare, happening only once every 10,000 to 100,000 years in a galaxy like our own. Future discoveries will help us learn even more about these uncommon cosmic blasts. Which occurs when a star passes too close to a black hole. Extreme gravity causes the star to bulge and break apart into a stream of gas. The tail of the stream escapes into space, but the rest swings around to form an accretion disk. This event, called Assassin 19BT for the
In systems governed exclusively by gravity, objects farthest away from the center would take the longest to complete an orbit. But in many galaxies, stars on the outside are orbiting at almost the same rate as those in the core.
It's almost like a phonograph record. Every part of that record spins around like a solid disk. The stars are going too fast to stay bound to the gravity of the galaxy. They should just fly right off into space.
Physicists come up with an explanation. Galaxies sit in a giant halo or ball of invisible dark matter. And it's that extra mass that allows the stars to turn fast, all the way out to the galactic rim.
Think about actually taking a disk of dough and spinning it to make a pizza. The more you spin it, the more those outer regions go farther and farther away.
Eventually, the dough just goes flying everywhere. That's what would happen to a galaxy if it weren't for dark matter. But as you spin pizza dough and you spin it faster and faster, it does hold itself together because there's all this yummy gluten that's acting as a glue. Dark matter is the gluten of our universe.